Switches and crossings are responsible for over 20% of infrastructure-related delays, and they have a major impact on operational capacity. Connox Switch leverages our IoT devices, AI, and machine learning, and is the only system that is capable of combining track and signal insights to enable higher operational quality and managing switch and crossings. It is the holistic switch solution that continuously monitors the traffic and health of key switch components, including trackbed, crossings of rod, blade, and point machine. This demo focuses on trackbed health. From this section, you can see how the overall health of your assets is changing over time. Here you can see all your assets locations in the map view. You can see the most recent maintenance activities here and the most degraded assets here. In the last section, you can see what's happening in terms of the usage of your switches. In general, the dashboard gives you an overview of all your critical assets, what the most recent and important events are, and which ones you need to take actions on. Here you get an aggregated information for a specific switch. You can locate the assets visually on the map here and see key metrics of trackbed health at each location from the summary. In the graph section, you can see how the vertical displacement has developed in the past and how it will develop in the next 90 days. This is an example of multiple unsuccessful tampons, and it was confirmed by our customer later. You can see that the vertical displacement was over the 3 mm threshold defined by the customer. They found out the problem and carried out a manual tamping, but it did not reach the desired result. The good thing is that they were able to see that right away, so a few days later they arranged another manual tamping. But the vertical displacement value got back to the previous level in a matter of days. The customer then implemented a speed restriction to sustain the condition, so that they have more time to plan for machine tamping at a later point in time. Imagine you're a maintenance engineer. You carried out an activity and you have no idea whether the activity was helpful or not. Sometimes it wasn't, and we even notice examples of activities that actually made things worse. Here, you can track the most recent activities on the switch you maintained. You can assess whether the activity generated your desired outcome and whether it has sustained at that level. A secondary way to verify and cross-check your maintenance activities is through AIVR, which we have integrated in our system. You can view the latest inspection images and video footages captured at each asset location to better evaluate the status of an asset. For example, you can familiarize yourself with and assess the surroundings of the site in advance, so that you know what you need to bring and what to prepare, and better plan your inspections and maintenance activities. In the future, downward-facing cameras can be used to support or even replace certain inspections. In addition to the AIVR platform created by One Big Circle, we're also in discussion with other integration partners to collaborate with to generate more value for asset managers. If you would like to learn more, I would be happy to introduce you to my colleagues. So being able to know immediately when a maintenance activity did or did not work is great, but ultimately you'd want to know in advance which methods works best for your different assets and why. Maintenance View helps you with an overview of all trackbed maintenance activities in your region. It helps you evaluate the overall effectiveness of different methods so that you can optimize them in the long term. Another indicator to help you plan for the long term is load. What is load and why does it matter? Load is used to indicate the usage of the assets, as the combination of train speed and tonnage is a good proxy for asset degradation. For example, DB uses the maximum allowed speed as an indicator for load. Others use UIC groups, but these load categories used for inspection cycles are either very broad or based on outdated and inaccurate data, and has resulted in many under and over inspected assets. The Connox load factor combines tonnage, speed, and the number of trains. With this, you could examine how each switch is utilized and explore the potential factors that are driving degradation. One of our customers, for example, used our data to extrapolate the correct load categories for all of their assets, not just the switch, which would allow them to save close to 30% of maintenance costs. So if you had to prioritize, you might want to start with this one, where you have a higher possibility of finding irregularities. We've now taken the usage insights from the switch to the entire network. My colleague can show you our newest product, Connox Network, later. But before that, as you can see, our user interface is very intuitive and easy to use. You can find all the resources you need in the Help Center. You can visit a tutorial video and access the walkthrough tours to help you get started. You can learn about the knowledge-based content. You can provide feedback or requests for support. And you can also learn what is coming next. Here you can see what we have been working on for point machine monitoring and predictions. We strongly believe that many point machine failures are in fact rooted in track irregularities, and the next step is to merge the two. Let me show you a short video of where we're going. So, by continuously monitoring the health of your key switch components, you can improve the capacity, reliability, and cost efficiency of your network.